Okay, well, this is the man here, the man, the myth, the legend, Thiago Porto.
Thank you.
And he's going to give a little talk about what's possible with machine learning.
Yep. So the idea of this was like more to show what is out there, like in terms of machine learning, because there is a lot of stuff going on. And I do believe that we, as a VFX artists, should be big part of that. And right now, it's being very specific to MIT labs. You know, all those guys, they're trying to do stuff that we want to do it as well. You know, so my idea for this presentation was more to show a few things that is out there and just create the idea that why we could have it, or maybe like we can ask for and try to track it and then see it. And only 2 VFX companies are actually investing a lot in machine learning. It's ILM and Weta, especially for 3D departments. And we can't find anything for like 2D, what they are doing for 2D. So there is stuff going on for 3D for sure, but not for 2D, at least not public. So what I'm trying to do in here is show some of they are trying to do, and then some ideas that I have that we could benefit from it. So this project, to me, was one of the best face replacement that I ever saw. I think it's really good in terms of details and stuff. And of course, they're using a lot of 3D to get these results. And, you know, I was thinking in terms of they capture, like you can see here, in a very classic way with, you know, with trackers, and they release this deep learning solver. So, of course, I don't know exactly what is doing that, but I do have some ideas of how they are doing this, and they use deep learning to try to predict how a human faces works, and they are trying to apply that for the target animation. But also, that is what they're calling retarget acting, because like if you shoot this guy on this age, it's gonna be some, you know, some details, some stuff that it's not gonna be present, and if he's young. So I think what they are trying to do with deep learning is predict what should be removed and then apply on the younger version. And you know, this is very cool, but like this is not 2D, no, this is not comp. This probably is going to be like a lot of stuff going on in 3D side, but no comp. And then same goes next project, this one. So this is from Framestar, and they also have this very close, the same thing they mentioned here, machine learning to solve. So in this way, what they're trying to do, it's using deep learning. I believe it's deep learning, but deep learning is part of the machine learning. So I believe they are using deep learning here. But here they're trying to do the same thing, but just quickly solve the animation of the capture and just quickly render something out before any animator just came in and just make better. So I think they're trying to do that for, you know, approving process or whatever. So as you can see here, and then, so they solve quickly by deep learning, and then they just start to animate it, and then they solve animation, they combine both words. Again, it's very nice, very cool, but again, it's 3D. Probably there's a lot of things happening in CG world, but not for us that want to like deal with the image. Probably we're gonna get some render passes or something. So how you can, you know, merge this world a little bit more using machine learning and just like make the comp help CG and CG help comp in better ways. So the next one is from these guys. To me, this is one of the biggest guys. They've been doing a lot of investment in research in a lot of areas for machine learning, and especially one for us, visual computing and computer vision. There is a lot of stuff going on, not only for machine learning, but for a lot of stuff. So one of them, for instance, that I want to show you quickly, just to see how these guys are doing. So someone is trying to create a specific eye rigging just by analyzing image. And then if you scroll down the paper, there's a lot of stuff going on in here. So it's like crazy, but one specific is this. So they figure out a way to tracking and create a rig for the eye And by doing that, you can just UV warp that, and then you have an eye to blend. To easily visualize what I'm saying, here's a video.
We present a method for person-specific eye rigging.
And then if you go in here, I can just go for the best part.
Here we show the images corresponding to approximately 50 input poses for which we fit accurate eye position. The reconstruction accuracy is demonstrated by overlaying the limbus, eyelid interface, and visual axis on top of several input views. The eyeball is coated by a protective layer called a conjunctiva, which is not firmly attached to the eyeball, but slides over it during rotation. As a consequence, the veins in the conjunctiva...
So, just this pass alone. So they managed to get an eyeball and stabilize that. And now I as a compositor already can see a lot of tricks that I could do to have this power in my hands. I could maybe have a shot that I could have something and then get an eye pass and then maybe offer to a client, like, do you want to close the eyes? Or do you want to move the eyes? Things that we for sure could be doing also in 2D. But for now, all of this investment and all of this stuff, it's being very restricted to 3D departments, especially when it comes from Disney research. So just to show, like, someone actually start to think about stabilized eye and have maps, or maybe, and using 3D renders those realistic eyes, like we can see in the end here. Just blows my mind that they actually have a team specific for that, So I was thinking, it's still very 3D, but not 2D. Then you have another paper, this one, that what they're trying to do with something that we as a compositor really like, which is create a geometry from the face. And this for me is one of the best projects so far. Like, they are doing a lot of good research to trying to extract geometry from the face, and then can be worked like in very interesting ways. Like one of the videos for that I can show you quickly. I'm not going to put it out at this time, but in here you can see
person-specific wrinkle.
Look at the levels of how good is that extracting. This is almost real time, And then they have even like this software that can easily extract the image. Like, if you go a little bit more, they're comparing. Look at that on the right side, all this part over here. There is no tracking. There is no tracking markers. There is nothing. It's just about get a camera, 2D camera, and extract a good mesh geometry. So, like, if you can get this in 2D, we already can do a lot of stuff, And then, again, they've been investing a lot, and all that goes to 3D department. And then, after this, there's the Medusa Project. Anyone knows what Medusa Project is? Medusa Project, to me, is one of the best projects so far. So they managed to get this is the level of quality they can now get from a 2D image to extract. Look at that. Look at how the quality of, this geometry is just crazy to me. And then I have a video here showing the animation. Look at the details. So Medusa Project was a very big deal for these guys. And then this was of the project that ILM is being using an Irishman. So if you can see, like, in few frames in the making of, we can see this thing, like Medusa Cam, that confirms that it's a Medusa Project. But so they extract all of that geometry on this level to get working. So, like, this is really cool. And, like, very, very few people is talking about how far these guys are going with machine learning. And yet, like, it's very hard to find information public. It's very, and we, as a VFX artist, we should be knowing about all of this, because this is going to be a game changer. And then they use an Irishman, and then they use the flux solver to predict and retarget, because now you have a geometry that was tracking based on the image. But now you need to extract the information and retarget the acting, but still keep all the, the nuances and everything, but in that 20 years young version of the same. So you need to know what you have to remove from the animation. This part was just to show like this is all amazing, but this is all going directly to the 3D departments. There is, at least not public, no one is talking like these things also, in my opinion, should be coming to 2D. We should be trying to do stuff like this and maybe push Autodesk and ask for this type of things, or trying to find companies or whatever to push the levels that I believe we should be asking for to get in 3D, in 2D. So my next idea was, so can you somehow not get in that level, but like what we can do now that we can actually start using machine learning? How I can get all of this craziness thing that is happening in machine learning and bring that to our world, to 2D, So what I'm going to show now is just like me experimenting stuff. So like sometimes it's not the proper way of doing, but it's just like trying to do something that I think it's our Flamey artists should be push the level of VFX artists, So we start quickly seeing something really cool that was Autodesk. The guys here started to implement models inside Flame. That to me, like, I was really happy to see this happening. Like, it's something, no one was doing before. So we have a 2D application that has models that can now extract things like ZDF, like, passes. And then that's why I thank you guys, because just having this in Flame now, I think it's good starting, a good beginning. And if you look around, there is no other company investing like in having this. So I think this is the right path. Then like not only this, but like the other one is like just more stuff that we already have in Flame, that like segmentation mask, like relighting, like things. So it is a beginning. It is super cool, at least to me, to have that already. I think it's a good beginning. And the idea that I have now, it's like, I saw these papers online. Like for instance, this one, imaging painting. And this is about, they are trying to use Auto-encoders or GANs to trying to recreate an image. So what you are seeing here is someone cut out the image and is pushing the neural network to reconstruct the data by learning from 1,000 of images. So this is really good stuff. And then I was like, cool, this is amazing. So this is something that we can already have in Flame. It could be awesome to have it. It's like automatic painting that you can just draw a shape and then have a paint. That to me, I don't know, but I'm sure that everyone here spent a lot of time painting things, and it's just a different face. If you combine all the experience that we have now, probably gonna have years of people doing the exact same thing, the exact same time of painting, and then the exact same type of extract all the tricks that we as a 2D know. How like we paint, it's blurry, then you have to bring the text over and blah blah blah. So I was reading all of these papers and I was like, man, this is amazing. And then I was like, the next one I found was this one. This one, they are trying to do the same thing, but more for background. Someone here was asking for a painting background and reconstruct the background. So this is exactly what they're trying to do right now. But what is happening is those guys don't have any VFX people helping him, So they are trying to do stuff because they know and they have ideas, but like we are the guys, we are the people that actually knows what detail is, our clients, they are paying us because of details, not because like an average cutout and just putting back. So this model here was able to reconstruct, so they cut the image and then automatic putting back stuff by analyzing thousands of images.
So Joe, just as a little bit of background, what you're saying is that like the model here was trained on 50,000 images
Yeah.
of libraries, let's say.
Exactly.
And then it was given this image here with holes in it and asked to recreate it based on its experience looking at 50,000 pictures.
Exactly. So what's happening here is we train a model, and then after training against thousands of pictures, that model now knows what these pictures are, understand the data. And then if you cut out something and we push the generator to put back the data, that's going to happen. It's going to put back the data, and then we're going to have a cleanup stuff, you know? So that's based on the training. So this was fascinating. And the first thing that I tried is like, I'm going to download all the GitHubs of this. I'm going to make work. I'm going to have the best painting in the world. And then what's happening was my first test, I took this video from Iva. He has this video that he created this amazing matchbox that I've been using a lot, that probably a lot of researchers have been using too, that's sequencing, separation, and then you paint, then you put it back, and then you do all the tricks to get the skin back, and so it's always a manual thing. So what I did was I took 2 screenshots of his video, and then I was like, can I have that same level as he gets quickly, and try to do the same thing with all those papers. So I downloaded all of them, and then I took those models, and then I tried to do it. And then one of the first paintings that I did was this. To me, it was horrible. I think you can't see it. Like, look, all of these details that you have in here, like, it's actually okay for what I've been training for, but it's like, it's not for us. With VFX artists, we know, like, what a painting is, what a skin texture is. So it's not actually a bad technology. It's just because it was training wrong. So I tried another implementation, and then this was a really interesting result. Look what happened with the eye. I love this. And then this is because the version is a little bit different. It's not trying to generate data. It's trying to what's called batch paint, was trying to find stuff in surroundings and try applying that. So, but actually, it's think that the eye should be on the top. So and look at this. This is really, really bad thing. So I try a lot. I try most all of them, and I get always like something close. No, something good for the average person, but they don't have our knowledge. They don't have a VFX knowledge of what the pixel means, what a person that spent 15 years of retouching skins knows, So I tried more and more and more. I could show a lot of results, but then I have an idea. If I think what was wrong was the data, was what they training for, so I'm gonna give a better data to be trained. So what I did, I took 90 years of my experience, and I took all the projects that I have, and then I started doing before and after of all my paintings that I did in the past. So because what's happening, those guys, they've been training a lot in models and data sets like this, like especially this one, Celeb A. So they have this data set that is a lot of people, a lot of famous people, and they can be training on top and use it. And they even have segmentation masks for each part of, which is amazing. But again, to us, VFX artists, that's kind of average. It's not actually the real data that we need. So I took all of my work, and then I started training these models based on my before and after. So I took the plate and I took the render, and then I will start putting that to learn. But what's happening was I need a loss function that we need a discriminator to understand what is right and what is wrong. And discriminator is really hard to control, but when you get it, it's really powerful. So what I did, I take a difference match between the plate and the comp, and I have a black and white image. That black and white is 00255, so I have data. So that data, it's actually being understanding and learning as well in the model. So that's what it's based to be painting. So what's happening was, I actually have this model that can now replicate what I've been doing in the past. You know, and that to me was like, okay, this is something interesting, because now actually the computer is learning, you know, from my experience. It's not just like tool that everybody should be just use it and learn how to use it. You know, when I was starting as a flame artist, I have this amazing flame Diego Moroni. He's a really good painting. And I remember when I was looking at him, he was reconstructing the whole frame by painting flame. And that to me blows my mind when I started like, I want to learn the paint and modeling flame and be a master on it, because he was painting with shadows, he was doing gradients, he was doing a lot of stuff. And to me, that was more an After Effects guy at that time, you know, more like a Photoshop guy. I would be doing all the tricks. I would be going to Photoshop, I would be doing After Effects, I would be doing Nuke, whatever, to make that task done. He was just sitting flame, painting. You know, with patience, he paints, and it was amazing. So it took me years to reach on that level. It took me like a lot of time to learn how the painting flame is, you know. Then suddenly, now I can actually paint in the same way, because, you know, it took me 9 years to learn. And then now I just can open Paint. For me, it's more comfortable than using Photoshop or whatever. So now what I did, I took all of my experience and I gave the machine to learn. And actually, my 9 years of experience was learned in 40 days of training. Just because I understand, like, this is about data now. This is about experience. So now I have a model that we're calling Thiago model that can actually replicate my paint. And actually, because I was doing a lot of, you know, we as a compositor, we usually do a lot of skin work to bring back those details. You know, sometimes we take some frame, sometimes you take the skin texture, you comp with vectors, whatever. So also that model learns, that neural network knows now how to reconstruct the data of the skin tones as well. So that to me blows my mind. So what I did was, I was using PyBox. What I did, like, I have this neural network that's working out with a model, and then I use the PyBox to open the model inside Flame. So I don't need to go out and do a lot of Python, whatever, so I can just then in Flame. So this is a quick demo. It's just like, to me, it's just like idea that the stuff that we can ask these guys here to be doing, you know, like for us inside Flame. You know, it's just concept idea, just like, guys, this is something that we could already have it. So I took those two screenshots. And now just going to do a PyBox that can write a frame and then read a frame back. So very simple. And then I'd open. And then now I'm going to open the main Python that actually call the whole structure to be able to use the model. So now when I hit editor, what I have is the interface that I can now use to paint. So just pausing here. So what I have now in here quickly is I have two models. I have the original model and I have my model that was trained. So my model, once again, was training all my experience. So now it should be doing close to Aya. If I was looking at the shot, I already know the result, should be doing the same thing, you know. So now what's happening is I start to painting brush. And I'm gonna hit process to say, like, this is the area that I need to be reconstruct. And now what's happening is, boom, it's done.
Because you trained it on the decisions you made for 9 years, it's knowing, well, if the shadow's coming from the left side and
Yeah,
it's on the
exactly.
cheek, I should use this kind of brush and maybe clone from this way, based on your experience.
It's based on experience, but it's not that smart. It's more like it's learn all the results and it's gonna try to replicate that in the moment that I cut. So it's trying to find close data.
Mhm.
and then just generate that data that's been learned. It's like, oh, maybe this part is close to what I've seen on that picture, something. So it's just about data. It's not actually about like, oh, I'm smart enough to make new decisions, but it still was able to replicate my painting. That it was like a lot. It took me years to get in the level that the same flame guy has it, And now this model was trained in 2 video cards for 40 days. And now I have this model that can now apply in 30 seconds the same level of painting.
I think that deserves at least as good of a round of applause as I got for explaining.
So just to make sure that I'm understanding this, you basically took your past before and after shots.
Yeah, and a different pass.
And you built in a difference, just like a plain old difference map that you would build in Flame.
Yeah.
And fed that into, and you built a model, fed that into the machine learning, and that is what's generating.
Yes, there is a few type of networks. That is, for instance, autoencoders. That is one type of networks. It's a way of they learn data, and there is GANs, which is very powerful. That I'm going to show you later on. That it's to me is going to be the game changer for 2D artists, and so. Autoencoders, for instance, they use a convolution process to take the data and extract. For instance, you have an image that is 1,000 by 1,000 pixels, so it's really big. So what the convolution process is going to do is going to try to shrink and compress the image in a lot of filtering and layers until get filled in a fully network that can be training. What's happening is it's so hard to train at 2,000 pixel images or full HD image. So this beautiful thing called CNNs, convolution network, it can extract the data because image is data, it's zeros or ones. So it start to detect features, and then in the next layer it's gonna reduce more, and then it goes on, and then your same full HD image, it's now 10 by 10. So let's pause for a second. I'm gonna add some visuals here to explain better what CNN means. So long time ago, a good flame artist and my friend Jorge Pereira, he once told me that we need to think in pixels, that we flame artists need to do that. And that ended up to be true. But best of my comps is thinking about pixels. So if you think about it, now with CNNs, we can actually make a computer to think has pixel, let's say so. So let's say you have this image. This is just a number. Let's add here 3. So this is a 2D image painted and nothing else, right? So let's add this as a first layer on a CNN. And boom, now we have our image get analyzed and turned into data, because essentially image is data. Now, in the next layer of the CNN, it's breaking out to try to identify exactly what pixels makes that tree special. And then in the next layer goes on. And then what's happening, each layer, the resolution is getting down, until it gets far in the top to get fully connected to be trained. That means on the train level, you're actually just training what makes that picture special. It's just the features, but they are still connect. So if you see here, they are still connect with the pixels that exactly make this unique. As you can see, this connection, they are all connected to the original resolution. So that means we are training in pixels, but we are still have the original data. This is so cool. Okay, let's move back. So similar what is going on here, but it's just like be able to extract that out of that image and create a data and learns, and then now it's able to replicate. To me, it was like a main goal. And this can be a game changer because it's all about data. For instance, who here would give your experience now? And then, this model can now take your frames before and after and analyze those and have your style of work, and then now someone that you never heard can just take that model, hit enter, and then your experience is going to be applied. You know, so this is something that is coming, and then to me, you should be talking a lot, and no one is talking, because this to me is going to be a game changer. Because now we have software that can actually apply experiences. You know, it's that for me, this was like a test, and was just me trying to figure out how this model is and GitHub and how they work, and then I decided to apply my thing. So if you actually can have people and investment to do this, we can actually have a flame. Because what I want to say here is like, I don't want to have something that routes to a pie box that writes a single frame that going to open a new interface. Then I have to do something that I got to close, go back to Flame, and then rely on that bridge. I want to have something built in Flame. You know, I want to have a Flame that I can open my 10,000 pictures of matte paintings, and then I'm gonna create my own model, and then I can have Flame just to read that model. And now I can just use when I comp. You know, I bring in my USB drive, and then I plug it, and I'm gonna put my model in the folder, and then I'm gonna use that a matte painting model reader or something like that. It's just like ideas that I think we should start talking about it, because it's really powerful. It's really powerful word out there, and only like MIT Labs is talking right now. You know, even VFX companies are not talking, and I think it should be, because, and we should be in the front ground of this technology. No.
So if we uploaded all our before and afters to these guys, would it be speed things up?
That's the key, right? And this
Exactly.
is like what's the, let's say, the problem with it. And I'm actually curious to know how many before and after you actually did, because you'll get better results with like
Actual-
a lot more before and after.
Yeah. Yeah.
So because we're actually doing the same thing, there's no like magic. So when we're doing something like the semantic here, we're just telling like thousands of times, this is an image, that's the sky, that's the map for the sky.
Yeah.
That's an image, that's a map of the sky. And then the machine is learning that this is the sky. So when you press the button, it
And now
goes and
no.
says like, yeah, I've looked at hundreds of thousands of images, that's the sky. I'm gonna create a map for it. So, and it's the key, because sometimes what is hard for us is to get that data.
Yeah.
Yeah.
It's the key is to get the before and after.
Yeah, to make that tool better, we have a segment here now. So have more data to train, we're gonna have better tools as well. You know, so I think data is a key. If you could get for this guy a lot of breakdowns, and you know, that would for sure help them in doing better research, and for sure you're gonna have better tools in Flame in the near future. You know, so all of these concept ideas was more to start talking about things. You know, how our work now is actually a data that can be passed to the future as well, and make our tool even better, you know, and have like a strong Flame.
So ultimately, how many samples did you actually feed your model?
50,000 pictures.
50,000 pairs or 50,000?
50,000, I cut out all my breakdowns in just this part, and then I have before and after of the same crop, and then I have the difference method to create a loss function.
So,
Yeah.
so a bunch, so I have like
15.
50,000 frames,
Yeah.
maybe 500 shots, or?
Yeah, it was not even that, because some shots I take a bunch of frames that I think like, oh, I have this pose, I have this pose,
You
I have this pose.
stabilizing your shots, so the face is in the middle.
No, I did some stabilizing, but I will try to get it a variety of different things. Like if I have a paint that I did that was turning this face, maybe the same face on this side has something interesting as well to be learned. So some of the shots I took like 5 or 6 frames to be learned. You know,
No, I meant
because-
like you're cropping so the head is in the middle.
oh yeah, I cropping from this part of it to this part.
'Cause that's part of what you have to do for the training data set, is you have to basically like align all the images and make them similar
Yeah.
enough.
It's making the process even easier, especially from the convolution part.
Mhm.
There's distracting data and then goes down until you get the feed. That is much better to get the same cropping. You know, it can be different, but then it just get difficult. So
I'm going to provide a counterpoint to that, because, like, from an artist's perspective, you're like, yeah, we should have these tools in Flame. But from a facility perspective, you're like, we want to own that IP.
because that's our look. So NPC are going to look at that and go, well, we're going to take our 4 best beauty artists, we're going to train our model on that data, and we're not going to share that with anybody else, because then people are going to come to NPC because of what we own in this thing. Like,
But then that's a
Sorry?
tool, right? Yeah.
well, no, because they're going to train
They're gonna put that in your contract.
But you're still going to require.
But then that's a tool. That's a tool.
No, but I'm saying
The tool
that's
is
why-
like it'll let you feed. What
No,
you
the
are.
machine will be smarter than the artist because the truth is not everybody is a good artist. There's not that many.
No, but I think the point I'm
So
trying
if
to
the
make.
machine learns how to do it automatically, then it's like, oh,
No,
make the film pretty.
That's not the point I'm trying to make. The
It's
point I'm trying to
awesome.
make is that the powerful thing, I think, what Autodesk can supply is the key to that, insofar as that we will provide the vendors the way to record that information in your own vault, because no one else is doing that. And I think that you can own a data, you're never going to be able to own a data, as Autodesk, you're never going to be able to get a data set that's suitable for everybody. It's just not going to happen.
Unless you're going to the Autodesk cloud.
But what you're saying, John, is that we need to do like a cloud service or something that was private, where you could upload your sources, it
Yeah.
would give you a model, and then it would delete everything, and you'd have a baked model.
Yeah, if you can
Yeah,
teach the machine.
I mean, if people want to share their model, then that's great, but I think the thing is that I don't think studios will want to.
Or even go further, make your own data set or like Thiago's.
Yeah, but the agencies find out that they own that footage, you can't
Exactly.
use it for something, so.
That's the thing, is that you own the work, but the images are
Look
still
for
by your
something,
client.
yeah.
But I'd like to hear the rest of the story.
Yes.
Yeah. So that's exactly what I was trying to do. It's actually create discussions about what we do now is data. You know, it's like, I think we are going, the next 10 years is going to be about data. It's going to be about models that was learned by what data that was, you know, even like, and it's been interesting. That's the main challenge of the AI community right now. It's about data. It's about, for instance, if they want to find a way of find cancer faster and easier, they need thousands of scans and information. And how they gonna go approach a hospital and ask for the same scans? The hospital gonna give that for free? You know, and then for who they are doing that. So that's applied to us too. Now we are actually creating, every time we deliver a comp, and not just deliver to the render, it's gonna be for 15 seconds spot on TV for a month, and then no one's gonna talk about. That's actually a data that model can be learned. You know, so it's whatever the model is you're doing is for yourself, or someone else is be doing that. So I think it's an interesting topic. We could be talking here the whole night about it, but that's one of my main goals, is just like start talking, because to me it's about data right now. Like the technology wise, like things that we can apply, models that we can generate. Of course we are going there, but you have to be careful about hyping too much the AI. But it's about data. We need to have good data to get better tools. So it's going to be about that.
What's the next demo again?
Do you have?
Oh, I was just gonna ask about temporal stability. I wondered if you found that the paint fix will bubble from shot frame to frame, or if there's any.
Like if it was applied to
The
a clip
infill.
as opposed to a.
Oh, okay. So now to my next, what I'm going to show next. So next, I had this idea like, let's do an example quickly that what we can do, even that tool is not yet in flame, but you could somehow try to use it and implement in our workflow, because this is what I've been trying to do. I realized that I was trying to build those interfaces and then, buttons convert to flame. That's just like, was such a time-consuming part. Then I realized quickly that was, instead of me trying to learn about deep learning, about to learn gather weights and better, models, I was trying to learn about how I'm going to create an interface for something. So I decided to move to get more, but my idea for this quick demo is just to show like we can still have tools already to be used up there on our normal workflow. It's just about renders, So for instance, this one, let's say we want to track something in my face, but it's still like, I will be talking a lot. I will be maybe, the eyes are going to be changing. All these parts are going to be a lot of details. If I'm going to try to do that with the motion vectors, that's gonna be a right solution, but we all know how the edges are when the motion vectors start happening. So we have sometimes the bad edges, sometimes like if I want my mouth to be open and closed, probably gonna create edges in between. Not gonna be like very good tracking because of that. So instead of approaching that with the regular motion vectors, what I did for the next step, there is an amazing tool called FlowNet. It's someone look how crazy this is. Someone had an idea to render a bunch of UV passes and motion vectors and give to be training. And actually they train it for 5 million times. So someone actually think about that, so this is crazy. And those people are not VFX artists. They are computer science, very talented people, but they don't have the knowledge that we have. And for sure it could help those guys do even better tools for us, So what NVIDIA did, they took that project and they implemented a better version as a SDK, so it can be used on any RTX card right now. And then after that point, what I did was just like just an interesting metrics to convert to a better UV pass. And then what I'm doing on this next step is what I like to call normalizing the UV pass. It's just like I'm passing the UV pass that I got from just metrics convert, and then I'm just adding a few frames in between and get this code to be doing something interesting in between frames. That's better than the native. At least for me, I found that it's better than the native zip flow motion vector that we have in NVIDIA. And then after that point, what I did was using deep reinforcement learning, which by analyzing a lot of young and old and the difference between those famous people, the model can understand the difference and try to recreate that as a new data. So I'm doing that for myself. This is kind of the same thing that's happening with those apps that we have. It's very similar. And then, so what I'm doing is just take a frame of that and use that normalized UV pass that I got. And then I'm putting back in Flame as a regular UV pass. And then now I have a much powerful motion warper to be playing, And then that's exactly what I'm doing right now. And then what I got in here as a result is this. To me, it was just a way like I can still have Flame, but I can still drive tools that is out there that VFX people should be using, and even give feedback for these guys. Like, guys, I work like at a very more interesting level of accuracy that I need to be on this, and maybe sometimes they're interesting. Like, let's implement that. Like what you have to meet has input data. It feels like that. I think it's something that we as a VFX artist should be pushing more, and actually no one is talking about. So the next one that I'm going to be showing is the demo that I did. This now gets very, very complicated in technical ways, but it's still, I was using Flame in kind of the similar way that I was using here, but then I was trying to do after I was watching Irishman, I was like, boy, those guys have something cool. And I was like, can we do the same thing as a 2D artist? Can we somehow, those guys have, ILM has Medusa Project with so much good detail to be tracked, has a UV, has whatever. They have Flux that can now, retarget acting. And so a lot of research and money and investment from the 3D department. But we, as a 2D department right now, we are just relying on passes and come back. And then we have fences too, we have it, but we still, the pace is kind of similar that we had before. So I was like, I want to help those guys more, Maybe I want to share some shots. Instead of they're doing all the work, maybe we can approach some shots and they can have other shots to be done. So that makes the process seamless. Or even crazier is, could we have something that you could apply in advertising work? So let's forget about movies, but let's do our work. Our work is not like how many spots we've been watching. They have the whole workflow pipeline to rebuild the whole face, you know, and then comp, and then CG modeling, and then tracking. That's gonna take months. So that's gonna be, I don't know, less than 1% of the commercials that you have out there, you know. So I was like, if you could have solutions that you can offer for our clients in advertising, say like, maybe you can do this as a 2D solution, you know, a fancy 2D solution. So after watching Irishman, I was like, I want to try to do this as a 2D solution with all the tools that maybe any machine learning can have. You know, we have Auto-encoders right now that are public. If you guys don't know, Auto-encoders is DeepFake. So when you talk about DeepFake, we are talking about Auto-encoders. So Auto-encoders has a big problem that they are really, really powerful, but they lack of resolution sometimes, and they, especially because some people calling them powerful denoiser, because that's what an encoder is. It's a denoiser. So we all know what denoiser is in the end. It's a blurry pixels. So for most good that a deepfake can be, it's still going to be limited by resolution and by the autoencoder output, which is a slightly blurry image that will be working amazing for YouTube. Then we have a lot of deepfakes that, man, they are really good. But for VFX, when you got clients, they're gonna arrive with our broadcast monitors, our 15-inch displays, and they're gonna look pixel by pixel. Any details, that's not gonna happen. So I start to challenge myself, like how I can try to do something with the machine learning tools that can be close to that, especially in terms of resolutions. So I found a few solutions for that, and one of the great things that a lot of talent people are trying to do is implement GANs on this network. So adding a GAN, anyone knows what a GAN is? GAN is a generative adversarial network. It means like they have two, let's say, guys. They are fighting each other. They are adversarial. And what they're doing, one guy is a generator and another guy is a discriminator. So what a generator does is it generates an image from input given data. And the discriminator does, it's fighting against this generator guy and say like, this is very bad. You know. And then what's happening is one can learn with each other. So especially the generator can learn by the discriminator. What's happening is they start to fighting against each other. And then what's happening is the generators start to learn how to make better data to fool the discriminator. It's very tech, but it's very, very interesting. Especially like GANs to me is gonna change. It's gonna change VFX. I can show you one example of GANs, for instance. This, it's based on GANs renders. And just for you guys know, those people are not real. Those people is a normalized data of celeb dataset, and using the generator to say, I want a new person that no one was seen before. So what was happening here is because of they are and this fighting, one is start to learning better to try to fool. Like, let me show you quickly. Here. All of those are fake people. They are not real. They are all being generated by a GANs architecture from NVIDIA's style GAN. So, and here it's not just about people, it's also about whatever data we fit in, you know? So here they have cars. So now what they're doing, they're trying to generate cars by doing the same thing. So this to me is a 2D thing, you know?
Yeah, like if you're a stock footage company, this is the end of buying stock footage from photographers.
Oh, no,
because
but no.
yeah,
but
well,
no.
I'm trying not to bring the room down. But yeah, here's the demographic I want. Okay, well, based on the million images I've learned from, we're going to give you somebody that's
what's
40 years old and white with red hair or something.
Like this is a This is style GAN is the version 2. So this is a better version. But what they show here is a version 1, which was creating those artifacts. So the version 2, it's actually a much better version that it doesn't create artifacts anymore. It's much better. And then look that resolution. Now it's 1,000 by 1,000 pixel. For us, it's nothing. But for architecture like that, man, it's away 1,000 pixels, you know? So like what's gonna happen in 5 years, you know? So like all of those are fully generated. They are not real. So by controlling the weight, you can have it, you know? So this to me is a 2D thing that we VFX artists should be having, you know?
Is that the process by which it is identifying and separating out?
They are controlling and just pass between average data, and it's like I want a person X, Y, Z, and then I want a person with something, and then just morph in between because it's just data, you know. So here this is the version 2. So look, these guys, the version 1, and they are crazy working hard to implement a version 2 that was better for the eyes, that was better for the artifacts, it was better. So they are crazy about pixel, like we VFX artists are too, you know. So I think it's merging those two words together would be for sure be amazing thing to do it, and no one has been talking about for 2D artists. Look at those faces. They are real faces. And just to show how crazy GAN is. Just to show how crazy GAN is. GAN was created in 2014. That was the first renders of GANs in 2014. And this is 4 years later. In 4 years, they came from, 10 by 10 by 1,000 by 1,000 and even more. So like GAN is really powerful, and I think it's something that can be changed or 2D department some point in the near future, you know. So just showed how in 4 years they managed to get so good that 4 years ahead, 5 years ahead, what came next, you know. So another thing that I want to show you that also actually is being using GANs. So those guys here, they think bigger. So what they're trying to do is using GANs, but instead of focus on faces, they want to focus on the whole body. But by doing that, they also are doing a pose estimation of a 2D camera, of a regular camera. And they say like, I have this person A that is doing a very bad acting or a very bad dancing. And now what I want, by tracking a pose estimation for any footage that I found, I want to have this person A doing whatever I found on that clip. So this is a fantastic work. It's still like very early stages, but again, look what cams in 4 years, you know. So like, let me show you some of the results of these guys. So they took this music video, and they are just dancing against the camera, and that is really bad. But by using GANs, they actually reapply the whole dancing of the A to another person. So let's look at that. Because it was hard to tracking, right? So they apply. Look, they're dancing. And now look, they're dancing.
Oh my God, incredible.
Forget about like, how long would it take to do a simulation in NASA?
So guys, this fantastic word is GAN. So I really recommend you guys go in Google and learn about generative transversal network because it's amazing. So
does anybody have any questions for you?
Yeah. I have the final clip to show that was about me trying to reach the level of de-aging and 2D work by using a lot of techniques. Maybe the same autoencoders, but just find a way to make them be better somehow, or maybe using what we're calling variational autoencoders. It's adding an extra level on the vector space and just create more details. So that allows us to maybe have more skin tones and details, So things like that I was just figuring out myself and try to learn, but I can even imagine have like a group of researchers doing that, and have like maybe us as artists or a company or Autodesk doing something really, really amazing with good investment and a good team that they know what they are doing actually, So this was the demo that I did quickly. There was a whole version that was not that good, but I have it. And then this was to me to show that if you want to control something, now we can't. And having very good details. Like you can see like the details of the skin, the variation and stuff. But that to me was not the best part. The best part to me was this. Because as a 2D guy, I want to be able to really relight a shot or a face, really have shadows, really have, have better lighting that UV maps maybe cannot help me, or, any pass that can try, it's good, but it's not actually an autoencoder that can actually understand, extract the data, understand what the features are, and reconstruct that data without shadow. It's like having a plate, the person without shadow. So this pass here is about that. It's about relighting and really have casting shadows and stuff by recreating the data and not actually apply a pass filter on top. And that's what I got. The reflections in the eyes.
Yeah.
Then here was again just, this is the implementation by like controlling better the eyes and stuff like that. And this was just to show that, if you want to find ways to generate data, and then this was the render.
What is the software that you're using
it's all on GitHub. It's all like you can find stuff in that and just trying to generate models, execute. Like I like a lot of them. They actually those tutorials to people to start doing it. Like you have like installation part, you have like generation part. So I just want to show now in Flame. So let's pause here for a second. Before we move to Flame, I want to explain better how I get this quality, or at least explain my workflow and see what you guys think. Quite some time ago, Ian Laquan, he is kind of the father of the modern AI, and he's really great. He has fantastic papers out there. I really, really recommend any one of you have a look at his work. It's fantastic. But he posted this. He was saying that it's better to train in small batches than actually have larger batches and expecting for quality. Of course, he's not meant to talk about what I was doing, but kind of worked to me as a reference or at least inspiration. So what I did, actually, I am, at least in the generation part, I'm generating the whole face, the model of the face with small batches, and that gives me the generation part of the data, at least the model of the whole face. So from this point, what I'm doing, I'm breaking out So now those models are gonna have larger batches, but those models are still connect to the generation part of the data. That means they are still looking back and sharing the same generation data. What this allows me was to getting a bunch of models, and those are not going to be flickering anymore because the generation part already knows the beginning of the data. So now I have a model when the face looks left, looks right, look up, and look down. And then on top of that, I actually have more extra models that is going to be looking just for the face, just for the details, like when it gets angry, when it get with the mouth open or the mouth closed, and that those models are sharing the generation of the pose that I need the mouth to be focusing. And all of those extra models, they have specific data to be looking at. So they're not going to be looking for extra data because they don't need to, because they are very specific task is when the depend of the pose, So in the end, I have this extra pass that it's with GANs, and then GANs is looking for specific data in specific models only. So depends of what was the result of the synthetic phase. I'm using extra bits with GANs to get extra details, and then the eyes look down, look back. And before I combine everything in one synthetic render, I'm actually looking for extra details with variation autoencoders to see maybe it was missing something when it get a smile, or so now because I have all break in models and each model proposed, I can specifically see in my synthetic render what is left, and then adding extra level of data and training and generation for the specific part of the framing. And if you want to generate this as one single process, so we're gonna need one GPU for each model. So each model is gonna have one specific GPU, so I can use the whole VRAM available for each. But to me, doing high-end VFX, that should not be a problem. Makes sense because you're dealing with good clients and high-end visual effects. So makes sense to me get the best of the best hardware to be trying new stuff. So that's it. Let's move back to Flame and see our results in comp. And then this is one of my first shots. And I'm praying, look, just for you guys see it. Oops. And then this was we have all the skin details already. If you compare before and after, and at least side-by-side version of that, where is shot 2? It's in here. This is a side-by-side version. And then what I want to show you quickly is, you see how many muscles and stuff are happening on the jaw part, for instance. You see, it's not just the whole thing, but it's very subtle, but this is what makes it real. So to generate that by machine learning, you have to create a very huge dimensions to be able to learn all of those data. And it's not about actually tracking, it's about reconstruct the data by adding a second network that it's this target face. Just to show you the same bit again, like you see those movements in there? If you go in the next one, in here, look all of those details and stuff. I have a close-up moment, but I will start with this one. And then if you move, you see, it's in there as well. All the motions, all the depth of the skin, all the movements in here. Like look in the eyes as well. Like if you see the right side eye, that is when blinks, it blinks. A lot of stuff happens to blink. When you go back against the plate, you can see that when it's blink, there is movements in there. It's not just about blinking, but it's have like a lot of information in the surroundings. So this is kind of okay shot because it's not that close. So I was pushing more, and then have shot 1. Where is my shot 1? Shot 1 version 3. This is kind of close-up moment. All this part around the mouth, you see, like when he talks, and all this part in here as well, and also in all this area. And because I generate the whole thing from this point to that point, I was trying to get details in here as well. And then when we compare this against the plate, shot 1, yep. This is version 3. Wait a minute, version 3. Yeah, it's this one. So this is comparing against the plate.
So Thiago, how much of this comp is, I mean, I know that you're getting like a raw output from the machine learning, but how much of this comp is happening in Flame?
It's happened, I have a screenshot in here just to show. It's a very basic comp. I try to not, because, you know, you could do a lot of tricks to make that even better. You know, like tweak the shadows, make masks, maybe some segmentation mask that is coming, you know, for the face, and just do the other stuff. But my main goal was like, I just comp against the plate. I did an overall color correction, and then I matched the grain, and then I did some refinements on the edges, and that's it. I was really trying to see like how far we can go before start to playing with 2D tricks, you know. So as you can see in this comp, it's just like I have the plates coming in, a lot of color correction to match it, and then I have some beauty tricks in here, and then I have some, you know, degrain, putting back some grains in the black levels, and that's like matching some. I use a 2D transformer to make he's a little bit skinnier, but actually I should do some warping, but it was just to get the idea of this shot in here. What I do like about this version, it's like, look at this area in here. See how many muscles inside the skin moves. This shot in here. This is a very tricky shot because he's not moving so much. That means we really need to get acting performance to be analyzed and reconstruct and autoencoders or GANs or variational autoencoders. Whatever it is, it's really difficult to get this size, all of those pixels, and still get like a good level of not sharpening too much in the end, you know, because the problem is we don't want sharp, we want crisp and clean skin, you know. So for instance, this shot, you see that there is fine details when he confirms, when he moves the eyes, when he trying to look, especially like here. I don't know if you guys can see it, but you see the eye when it moves. There is also a lighting casting and stuff like that, you know. It's just
so much detail.
Yeah, it could.
And on the before, like his eyes are almost closed.
Oh, good point. So, for instance, what was this shot in here? This was really, really difficult. Good point. It's because in the plate there is no eyes. You know? But what's happening is, if you want, well, we target the acting to 40 years earlier. He's not gonna close the eyes in that level because he's just young. So that means we need to figure out ways to have the eye open, but it's still doing that. You know, remember I was talking about convolution network, that we take the pixels, it downscale so much that's gonna be 10 by 10, 5 by 5, whatever. That is the trick to get eye to be read like this. This is just tiny pixels. So on the final version, you can see that the eyes needs to be a little bit more open because he's younger, but also it needs to be looking for something, you know? It's not just like the eye is going to be the flow. It needs to be so we need, in order to try to offer something like this for the clients, we need first be able to control, you know? It's not just like a solution that like, okay, I have something that I can analyze the data, hit enter to training for 20 days, and then hit OK, and then come back in the plate, and that's it. That's not going to happen because we all know what the clients are going to be asking for. So in order to offer this as an advertising solution, we need to be able to control. In controlling machine learning, it's really hard. Control a discriminator, for instance, there is talent people out there right now trying to control discriminator and add an extra layer on the neural networks, so in auto-encoders. So it's really hard, but it's really fun at the same time. You know, like even here, if you guys can see, oh, sorry, in these details in here, you know, like, and these details in here, for instance, when he moves the mouth, and then I have a very difficult shot 4. This is a longer shot, it's 230 frames, but it's just to show something interesting. Look at his hand in here. Look at that. It's being all reconstructed to be able to just masking the hands on top and just be playing with pixel spread or something, you know? So like these things that we need to, it needs to be controlling by offering as a solution, you know, like, oh, I want the eyes to be looking right. I want the eyes to be bigger. I want to be close, you know, I want to be able to, you know, the clients arrive. That's something amazing. Like, can you imagine the clients arrive in the section and now they can ask, can you close the mouth? You know, I don't like the mouth, was just like in the set, was too, you know, let's close the mouth. And now we as a 2D guys maybe can do it, you know, like by learning the right tools or even someday having in flame. And then just was my main goal today, was just trying to show you guys that like this amazing deep learning world that is happening right now, and we should be like learn, you know, at least be tracking, learning, see what's happening, and start to asking for stuff. You know, start to asking, especially data is going to be a new thing. So also data, start to think about what my work now is also data, or it's just like I'm delivering at a new spot. So it's, you know, things like that. I was trying to give you guys idea what is happening right now. And this is.
Let's give it up for Thiago. It was awesome.
We have we kind of have a unique opportunity here because not only do we have Thiago that's done some really pioneering, awesome stuff here, but we also have the Autodesk crew who's also dipping their toes into that same really awesome area. I feel like we have this unique opportunity to maybe have some questions. I mean, for me, just as an example, I see that you lifted out of one of those examples a motion vector pass. It seems like it's far superior to anything that we have in the tool set now. If I'm going to throw this to Fred and the team, Will, is that something that's even plausible that can be implemented in Flame? I mean, I feel like
you mean comboing the motion vectors with the...
No, just the quality, I feel like, of the motion vectors, or even that geometry that the Medusa system, nowhere near that level, but is that stuff something that we could leverage into our tool set? Is any of that stuff even possible as far as like, I mean, I know there's a whole sort of legality thing that could, you know, trip you guys up, but
It's definitely possible. It's a matter of how far you go to understand not just 2D solves, like figuring out a reference normal map and coming up with an equivalent normal map. Yeah. Or an example would be, you know, understanding the filling in the details, but to then actually like correctly map create a mesh, keep the topology of that mesh as it moves. It's just another level of the work. we've got the interest in our development team. We could definitely go there. I think it's just a matter of weighing it with all the other priorities.
Yeah.
But
Right.
it's
That's the
Thiago
challenge.
said the key is the data, right?
Yeah.
Because like if you're thinking about, you were saying like Facebook is like putting stuff out there, but they have all the images of the world.
Yeah.
And they have all the rights to those images, so they can easily build those like data because they have it.
Yeah.
In our case, when like Andre was saying like, oh, so we could like provide you your images, but do you think that your customers will let you share their images with us? That's what we think. So
It
like,
depends
So-
on how we structure the way that we acquire our images. And
but
like,
this
like-
is where it's getting like
my company
hard.
is also a production company, but I don't know what you need, right? So like, if you guys tell all of us like, hey, we need like all of your humans and all of their alphas. You know, if we tell our clients ahead of time, hey, we're going to use this footage to provide data, but
And
not
you're
the
right.
actual images.
You're right. You just need that you need to realize that we need tens and thousands and
Yeah.
hundreds of thousands images.
Yeah.
This is where it's getting over.
I'm not
Well, this
saying
is
targeting it to you. I'm saying you have a huge user base.
But this is what I'm saying is that I don't think that is ever going to happen. Because I think that you have to provide the tools to us, for us to be able to build those models for ourselves. Because I can give you a concrete example now, is in film, I do a lot of film work, and I can see this immediately for solving ADR problems. But like, they need the actor to say this is not the actor. So you either come up with, they bring them in, do ADR, and you find a cut of them facing away from camera. And every time you see an actor facing away from camera, normally it's because they've changed their dialogue. So if they can just change them to say that one word, in the Avid, you've got 400,000 frames of them saying this, all of their dialogue, and the camera is on them on a one shot like this. So you've got all this data, very high resolution to train them, and they can just change the line like that. They're never going to give you that footage, and that footage is never going to leave that studio, but they're going to want, or we would love that ability to train that model ourselves, to say like, let's do that and we can solve it.
One of the challenges of this machine learning stuff is it's only as good as its training set, right? So if there was some kind of mechanism whereby you could do a kind of a quick training for that type of shot in that environment and get a solution and then it kind of deletes all its data, is maybe what you're describing.
Yeah, because in an ADR situation, you're solving a monstrously expensive situation, because how much it can cost to bring in the actor again, to shoot a scene again, to do this again, but versus them coming in and just saying the line again.
It's like, never mind fixing it in post, it's created in post, manufactured in post.
But I think that like the hope for us is that there's more and more like people doing this kind of stuff. There's a lot more researchers and people that are actually sharing their data set. And like in that case,
Like
this is something that, so let's say
I
a
think
university is sharing its data set, we could reuse.
I think that's why you see companies like Disney and ILM, because they own the content and they're doing the research, and that's why they're deep in it. They don't have to ask anybody for the rights for performance because they do it. What's going to happen is the actors are going to word into their contract that they have rights for approval. Like I know on The Irishman and previous, he sits and approves his own recon. And that's in his contract. So you get into a lot of ethical stuff when you're using your footage without that. And God forbid you want Disney lawyers.
But the tools that we, maybe just worth mentioning that the tools that we've done so far, one of the reasons that we picked those functions like general depth, sky, human, is that those are the ones that were plausibly sort of generic enough. Whereas, I mean, it's like we could have done very specific training sets on a certain type of animal or whatever, but it would only have been good for that kind of animal, right? And it wouldn't work for any kind of different shape animal. Same with cars. Cars is problematic because there's lots of different shapes, number of doors, angles, reflections. It's far less predictable to get to a generic model that works for all cars.
Yeah, there is a strong AI community trying to create models that can simulate data and deliver back something to be trained. And yeah, this is a really interesting topic, and it's really, they are trying to reach right now. It's like, can we simulate a person, GAN or something, and that's gonna be a data set, you know, to be able to be, because it's so hard and so it's so sensitive, this what it is becoming now. For instance, we never thought before that our breakdowns on Vimeo could be actually be something truly valuable, you know. So to me before, it's like, I'm gonna share some breakdowns that I was allowed to do it, you know, like, oh, some video work that I never share breakdowns of video work, but now we can use just before and afters, and suddenly we create something powerful, you know. So data is very sensitive right now, and there is a lot of investment, like maybe it's a private way, like hospital are trying to implement a way of private data, so we can call the hospital and say, I want the data, and then the data comes to you, but you can't see it. We can just like decompress the data with another Niro, and then learn from that and give back to hospitals. So there is a lot of things that people are talking about right now in our community to trying to have access to data in private ways. So I think it's going to be the next interesting topic. For sure.
Ethical concerns are a big part of the conversation.
Yeah.
In the end, it's going to be the most important part of it.
Yeah.
All right.
Does anyone else have any other questions?
I have a question. You know, with all the experience that you've learned over the years, and also like going through the trial and errors of this, where would one would you recommend like start to try to implement certain things that you feel like?
I would say start with the libraries that we already have, like PyTorch or TensorFlow. Those are libraries that we have right now that makes easier to use. And if you just start searching about those, automatically we start going into that world, you know, because it was built for that. So I want to learn how to use this too. So, and they usually do like even like step-by-step process that you can just go copy and paste and try to. So it's just like an exercise that getting better and better and better by doing until you start to learn like what it actually means, like what architecture is, and what it's you know, a neural net means, and all that stuff. Like then suddenly you get in, if you go deeper, you start to learn. That's what I did actually. And also academic papers are really important, but it's really hard to understand. So it takes a lot of time to actually understand what they are saying. Sometimes they are saying very fancy way that actually it just blurs the image, you know. So but they have this very, very smart way of sharing knowledge, and then it's good to learn how they write papers, so we can actually understand and then quickly realize, oh, they are trying to do this, you know. So like things like that, it's interesting. Like just able to open a paper and see that the guy trained for 25 million UV passes, you know, things like that. You start to think like, oh, interesting. And then I was training for 1 million, and then I think it was bigger, you know. Like I think it's yeah, it just go deeper and deeper. It's very fascinating work. Yeah.
All right. Thank you, everybody. Thank you again to the White House Post and Carbon for being a great host. Thank you
to the guys from Autodesk also.
Yeah.
Citizens, thank you.
Thank you, Hobby. And
hang out for a little bit, drink some beers.
Yeah. We'll see you all soon. Thanks.